How might we remove a node from a linked list recursively? Well, imagine we've got a very simple linked list here. And this is usually what you want to do when you start thinking about a recursive function. Think about the simplest case imaginable. And that's a list with a single length of 1, right? So here we've got our list whose head node is b, and it is the only node in our linked list. So let's imagine a base case of something like remove, and the head node that we're going to be working with is this particular node here. And let's say we're trying to remove index 0. We're trying to remove the only node from this list. Well, what happens when we do that? We get back nothing, right? We get back null, because there is no other node for us to work with in this list. So this is going to result in a null value, right? Let's think about one other case here. What happens when we say remove head and we give an index that's greater than the length or equal to the length of our list? So here, head of index 1, what's the return value here? What is the result of this? Well, if we think about what is the index of this node, it's 0. There is no index 1, right? We don't have a node at index 1. So what are we going to do? Well, we're trying to remove a node that doesn't exist, so we're just going to return back head. And in this case, that means that we're returning back to you the same list that you began with, right? No changes happened. The intuition I want to talk through quickly before we look at the recursive case here is when you call remove, what you're getting back is a list to the head of the list that you gave originally, but with the element at index 0 or 1 or whatever index you provided removed from it. So let's imagine a slightly more intricate list here where we've got 2 nodes. And so with our second node in place, let's go ahead and link these up and say that the next node of our new head refers to a node B, right? So let's imagine a case where we're trying to remove this head node, or we're trying to remove from this list the very first element. So we would say remove, and our head node, let's imagine that it refers to this one here, and the index that we're trying to remove is 0. Well, what do we do? In this case, what we expect to get back is a list whose head is going to be B, right? If we remove A, we expect back a new list whose head is B, right? And so how do we get a reference to this node? Well, if our head is here, we can say the new head of our list is going to be head.next, right? So it's going to return head.next. And that's just saying remove index 0, or the first node of this list, starting from head, and we will return back to you the new head, which is this node here, right? So what can we do with this? Well, I want to point out a similarity here. All right, so we said that when we removed index 0 from this head node, it returned null. But that's actually just the specific value that we returned. That's kind of like saying that this is going to return this node value directly, right? But what's actually happening here is if we looked only at this node, its next is actually null. So one other way we can more generally think about what happened in this case right here is it's actually returning head.next, right? And it just so happened to be that when we called this function on a list who had only one element, the next property was null, right? So head.next in this case was indeed null. Let's imagine what's going to be our recursive case. So it turns out when we've got a base case happening earlier in our list, right? So it turns out that our base case is happening when index is 0, right? That's one of our base cases. Another base case was this base case here when we've reached the tail of our list, the very end of it, but we haven't found the index we're looking for. So let's talk about the recursive case, because this is where things get interesting, and there's something really cool that happens when you implement remove recursively. All right, so let's imagine we call remove, and we're saying, all right, we're going to remove head, which is this node here, and we're trying to remove the index 1. So what we expect back from this, right, is going to be a list whose head node is still A, but it's not going to contain B's, right? So we're going to imagine we have a list that's A to null, right? It doesn't have B in it because B is index 1 relative to this head node A. All right. So how do we think about how this is going to work? Well, what we're going to say is that recursively, as far as we know, we're not trying to remove ourself from this list, right? We're not trying to remove index 0. We're trying to remove an index that's further down in the list. This index is greater than 0. So why don't we say, you know what? We don't know how to remove an index further down in the list. So what we're going to rely upon is when we call remove again recursively, we're expecting that it's going to give us back the next node that we should have in the list, right? So when we say remove, and we're going to remove based on the rest of the list. So head.next is referring to the rest of the list. That's the same as this. And we're going to subtract 1 from the index we were looking for, right? Because we're moving our way down this list. And so here we're going to be calling remove head.next, and 0 will be the index. Well, it turns out this head.next is referring to the same head value we did when we were just looking at this single element list, right? So these two things are effectively the same. We know how to do that. And we know that it's ultimately going to return its head.next, which is going to be null, right? But we have this interesting thing that's happened. We're not trying to return null or anything like that from this remove step. We're trying to return the head of the list with this particular node here removed from it, with the B node removed from it, right? So we're trying to get rid of that. So what are we going to do? Well, there's a neat trick here, and that neat trick is this. When we make this recursive call, remove on head.next, we want to take the value that's returned by this call, which is going to be the next node, and assign that to heads next. Right? So let me just write this out. So we're going to say heads next node is going to be assigned this recursive call, right? And what we're saying here, the intuition is, I want the next node of the list to be whatever is the result of removing the index that we were looking for, -1, from the rest of this list, right? So we're saying, all right, I know that remove is ultimately going to give me back the new head of a list with this particular index removed from it. And so we've sort of shifted the problem down to the function call beneath us. And so head.next is going to be the result of removing head.next at index 0. And then what we would do, so what's going to happen is when we say head.next is result of remove head.next with 0 as the two arguments, we know that's going to resolve in head.next, which was a base case, and when we're dealing with only B, that's going to be null. So what's going to happen is head.next is going to be assigned a reference to null. And finally, we're going to give, as a result of this function call, a reference of the head node back. And this recursive step works no matter how many nodes we have in this list, right? So I would encourage you, if you're trying to solve this problem using some recursion, to spend some time thinking through what we've just discussed here and trying to implement it on your own. The key intuition I just want to come back to one last time is when we are doing the recursive step, right? And we are trying to remove a node that comes after us. The key thing that we're going to do when we're not in our base case, when we're in our recursive case, is say, all right, I don't know necessarily, I need to change my next value to be whatever is the result of calling remove recursively, right? And if it turns out that we keep calling remove recursively and we haven't yet reached our base case where the index is 0, in those cases, nothing's going to change. We're gonna maintain the same link to the next node. But in the case where we actually are removing a node, we're going to get back the reference to the next node after the node we're removing, and that's going to be assigned back to where we came from. This one is a little bit trickier of a recursive function, but once it comes together in your head, it's incredibly beautiful and rewarding, and I think you should try it.